Hello, welcome back to the Red Planet Project channel. In previous episodes, we have already discussed why we want to terraform Mars and what challenges come with it. Today, we will dive into the first concrete steps that humanity must take to begin this transformation. Terraforming Mars is not just about science and technology, it is also a great passion. It is the dream of a future in which humanity crosses new frontiers and conquers new worlds. This topic has been explored many times in science fiction literature, and one of the most famous examples is the book Red Mars by Kim Stanley Robinson. It tells the story of the first colonists and their attempts to transform Mars into a habitable world, addressing both technological and social aspects of this process. But is this just fiction, or could it soon become reality? Let's find out. The history of early ideas about terraforming Mars. The first concepts for transforming Mars appeared in literature as early as the 20th century, when scientists and science fiction writers began speculating about methods to alter the planet. In the 1960s, Carl Sagan suggested that using greenhouse gases could gradually warm Mars's atmosphere. Arthur C. Clarke wrote about the possibility of artificially heating the planet using giant orbital mirrors that could reflect sunlight onto Mars's surface. Robinson's Mars trilogy, Red Mars, Green Mars, Blue Mars, depicted a potential course of terraforming, presenting both the technological aspects and the political challenges related to colonizing a new world. Since then, the topic has evolved in both scientific research and popular culture. Terraforming theories have developed from simple ideas like melting the polar ice caps to more advanced concepts, such as building an artificial magnetosphere to protect Mars from the destructive effects of solar wind. Today, we know that terraforming is no longer just an idea from science fiction books. It is a real subject of scientific research and technological development that may one day make Mars more hospitable for humans. Now let's take a look at the technologies we already have and how they might help us take the first steps toward transforming Mars. Over the past decades, space exploration technology has advanced significantly, providing the necessary tools to begin the process of terraforming. We now have several key technologies that could play a fundamental role in transforming Mars into a more habitable environment for humans. Interplanetary transport, SpaceX, and Starship reusable rockets that will enable the transport of people and equipment to Mars. Starship is currently the most advanced transportation system designed to carry large payloads and humans to other planets. Thanks to its reusability, it significantly reduces the cost of space travel. Exploration and analysis of Mars's surface. Exploration robots, rovers, such as Perseverance, Curiosity, and Opportunity, have provided us with crucial information about the composition of the regolith, the atmosphere, and the geological history of Mars. Their data helps in planning future missions. MOXIE Mars Oxygen in Situ. Resource Utilization Experiment, an experiment that has confirmed the possibility of producing oxygen from the carbon dioxide in Mars's atmosphere. In the future, similar devices could supply oxygen for astronauts and serve as a key component in rocket fuel production, autonomous support systems and aerial surveys, drones and autonomous vehicles. For example, the Ingenuity helicopter, which has proven the ability to fly in the thin Martian atmosphere. In the future, drones could be used to explore hard-to-reach areas, transport small payloads, and map terrain. What technologies do we still need to develop? For Mars to become more hospitable to life, several key technologies must be developed. Terraforming is not just a scientific process, it is also an engineering and logistical challenge on an unprecedented scale. The most important aspects that need to be developed and refined to make the transformation of Mars a reality. Large-scale oxygen production. Currently, the MOXIE experiment aboard the Perseverance rover produces small amounts of oxygen from Martian carbon dioxide. For colonies to function, it will be necessary to create large reactors for mass oxygen production, as well as systems for its storage and distribution, temperature control, and planetary heating. Mars is an extremely cold place, with an average temperature of about -63 degrees Celsius. Terraforming requires methods to increase this temperature. Potential solutions include giant orbital mirrors that could focus sunlight onto the planet's surface, the release of greenhouse gases, such as fluorocarbons, and nuclear explosions that could temporarily heat the atmosphere, melting the ice caps and releasing CO2. Protective magnetosphere. One of the biggest problems on Mars is the lack of a protective magnetic field, which causes the planet to lose its atmosphere due to solar wind. NASA is considering building an artificial magnetosphere placed at Mars' L1 Lagrange point, which could shield the planet and allow its atmosphere to gradually rebuild. Artificial ecosystems. Future colonies will require air, water, and food recycling systems. Research is currently being conducted on closed biospheres, such as BIOS 3, and projects based on hydroponic and aeroponic systems. Advances in microbiology and genetic engineering could help create plants and microorganisms that adapt to the harsh Martian conditions. Increasing atmospheric pressure. The current atmospheric pressure on Mars is about 0.6% of Earth's. Terraforming requires methods to increase the amount of gases in the atmosphere to allow for breathing without spacesuits. Possible methods include releasing CO2 from the regolith by heating the surface, melting the ice caps to release carbon dioxide, and introducing chemical reactions that gradually densify the atmosphere. Advanced construction technologies. Mars lacks infrastructure, so it is necessary to develop technologies that enable habitat construction using local materials. Possible solutions include 3D printing with regolith, which allows for building shelters without the need to transport materials from Earth, modular construction using prefabricated elements delivered from Earth, and lava tubes that could serve as natural shelters against cosmic radiation. Psychological and social aspects of terraforming. Long-term stays on Mars will impact the mental health of colonists. It requires the development of strategies to cope with isolation, stress, and potential social conflicts in extreme conditions. There is also the question of whether Martians will begin to create their own independent culture and society. What will be the first practical steps in terraforming? The strategy of terraforming requires well-planned actions to ensure that each step is effective. The first step is building the initial bases and providing protection from radiation. Mars lacks a strong magnetic field and a dense atmosphere, making its surface vulnerable to cosmic radiation and extreme temperature fluctuations. Solutions include lava tubes, which can serve as natural shelters, underground bases in caves or excavated tunnels, and pressurized domes made of advanced materials that would block radiation and create a controlled microclimate. Producing oxygen and water on-site is crucial. MOXIE can produce oxygen from Martian carbon dioxide, while drilling and electrolysis systems will allow for the extraction of water ice and its conversion into drinking water and rocket fuel. Water recycling will be essential to minimize losses. Energy production requires selecting efficient power sources. Kilopower nuclear reactors will provide a stable energy source independent of sunlight. Solar farms will supply energy if positioned in optimal locations. Geothermal energy could provide additional heat for colony operations. Growing plants and producing food will be essential for the long-term presence of humans. Hydroponic and aeroponic systems allow plants to grow with minimal water consumption. Various plant species resistant to Martian conditions are being tested, and genetic engineering may help create strains adapted to extreme environments. Atmospheric changes involve the release of greenhouse gases, such as fluorine-based compounds, to enhance the greenhouse effect. Nuclear explosions at the poles could help melt the ice caps and release carbon dioxide. Orbital mirrors could direct more sunlight onto the Martian surface. The psychological and social challenges of terraforming include designing colonies in a way that supports mental well-being, psychological training for future settlers, and isolation tests conducted in Earth-based simulations. Terraforming Mars is a long-term process that could begin within this century. The key first steps include building bases, producing oxygen and water locally, securing energy supplies, growing crops, and gradually increasing atmospheric temperature and pressure. This is only the beginning of a long journey, but technology and determination can make this process possible. Imagine Mars in the year 2012-25. What once seemed impossible has become reality. Mars is no longer just a barren red desert. Humans have permanently settled on its surface. Look at it through the eyes of future Martians. You wake up in your habitat. Outside your window, you see vast domes protecting the colony from dust and freezing temperatures. And on the horizon, the first green enclaves, Martian farms supplying food to the settlers. Gravity, 3 times weaker than on Earth, makes your steps feel light, almost like an astronaut's leap. You head to work. Are you an engineer constructing new lava tunnels for future settlers? A scientist studying Martian microbes? Or perhaps a pilot of a transport ship traveling between Earth and the Martian orbital station? Mars has changed beyond recognition. Some say this is the beginning of a new civilization, one separate from Earth. Will Martians think differently from Earthlings? Will new values, holidays, and traditions emerge? Or will Mars, with its harsh climate and limited resources, force people into a new way of life? More disciplined, focused on cooperation? Share your visions in the comments. Maybe one day, someone watching this will actually live on Mars, and what seems like science fiction today will become their everyday reality. Mars could be a key step in the further exploration of the solar system. Mars may only be the beginning. If we succeed in transforming its environment, it will pave the way for the exploration and colonization of other celestial bodies, such as the moons of Jupiter and Saturn. It is possible that in the future, humanity will embark on missions toward exoplanets. Will humanity be able to establish a permanent colony on Mars? What challenges will be the hardest to overcome? Share your thoughts in the comments. If you enjoyed this episode, leave a like and subscribe to the channel so you don't miss future content. See you in the next episode of Red Planet Project.